Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish Fahmi Beza and I am a leader for this experiment. And we are from group 6 and today we will present about the experiment 6, which is Bourdon tube pressure gauge open-ended experiment. For the introduction, Bourdon tube gauge is consists of a tube bent into a coil or an arc, and then a pointer connected to the end can be attached to a lever and pointed calibrated to indicate pressure. As you can see in the slide, there are some reference that we can take as examples, so we know how it functions. And most commonly, Bourdon tube gauge are used in many areas and used to measure from medium to high pressure. Bourdon tube gauge are well known as a Bourdon tube, and then this tube move outward when the pressure inside the tube is higher than extended pressure, and it move inward when the internal pressure is lower. This motion is directly proportional to the pressure measured and it's coupled to the pointer mechanism. There are few advantages by using Bourdon tube gauge, which is it is accurate compared to other instrument, especially when we want to measure the high pressure. However, Bourdon tube gauge also has its own disadvantage, which is Bourdon tube gauge are very sensitive to the vibration and shock. Next, we move on to the objective. The objective is for the experiment is to calibrate a Bourdon tube pressure gauge using dead weights. Next, we jump to the theory part, which is as you can see, the photo is the setup for the experiment. Bourdon tube gauge is loaded. Bourdon tube gauge is loaded with non-pressure using a dead weight tester will be used for calibration. There are photo in the slide that we can use as a reference. So for the theory, the use of piston and weight with the cylindrical generates a measurement reference pressure, which is P, and P is equal to force over area. So P equal to F over A. F indicate the force applied to the liquid in the calibrated cylinder, which we measure in Newton, and area is a cross-sectional area of the piston. And to get the area, we can use the formula which is area equal to pi d squared over 4. D indicate the diameter of the piston, and then to get force, we can use the formula F equal to mg, which F is the force applied to the liquid in the calibrated cylinder, which we measure in Newton. M is equal to the total mass, which we measure in kilogram, and then G is the gravitational acceleration. As we know, the pressure generated on the Bourdon type pressure gauge is due to the weight applied on the piston are directly proportional to the increment of the weight on the piston.
My name is Lim Xinyan, and I'm going to introduce methodology. Apparatus. In this experiment, we will use Bourdon tube pressure gauge, dead weight tester, and 1 kg piston. Procedure. The piston was put into the cylinder. The air bubbles were cleaned from the tube. The first reading of the pressure gauge was recorded. After that, the weight of 0.5 kg was put on and the second reading was recorded. The weight of 0.5 kg was increased and the third reading was recorded. The steps are continued with all the dead weights provided until the total mass of 4.5 kg was reached and all the readings were recorded.
Next, I am Nur Arina Izzati binti Sulaiman will explain on the result. So, this is the experimental data that we obtained throughout the experiment and some calculation made throughout this experiment. Now I will show how we conduct the calculation throughout the experiment. Firstly, we need to know the piston weight, which is equal to 1 kg, and the cross-sectional area of the piston is equal to 3.1731 times 10 to the power of negative 4. The first step is we need to calculate the actual pressure exerted by the piston. To calculate this, we need the formula, which is the mass of the piston times with the gravitational constant divided by the cross-sectional area of the piston. So, we obtain the actual pressure exerted by the piston is equal to 30.9161 kN per meter square. Next, for the step 2, we need to calculate the actual pressure exerted by the total mass. The formula is equal to the total mass weight plus the piston times with the gravitational constant and over by the cross-sectional area of the piston. We take the example for a total mass for 1.5 kg and we obtain the actual pressure exerted by 1.5 kg is equal to 46.3742 kN per meter square, where kilogram meter per second square is equal to kilonewton. This calculation will be repeated for all the total mass. Next, we need to calculate the mean value for the pressure of gauge reading. For 1 kg of mass, the mean value for the increasing pressure is equal to first reading plus the second reading and plus with the third reading divided by 3, and we obtain the mean value for the increasing pressure of the gauge reading is equal to 34.167 kN per meter square. Next, for the mean value for the decreasing pressure is equal to first reading plus the second reading and plus with the third reading divided by 3, and we obtain the mean value for the decreasing pressure of gauge reading for the 1 kg of mass is equal to 35.5 kN per meter square. This calculation doing for all the total mass along the experiment. For step 4, we need to calculate the relative and the percentage error. This is the relative and the percentage error for our experiment for all the total mass. In order to obtain this relative error and the percentage error, we need this formula. For the relative error is equal to the mean of the increasing pressure or the mean of the decreasing pressure minus by the actual pressure for the total mass, and we will obtain the relative error calculated for each of the mass. For the percentage error, from the calculated relative error for the increasing pressure number 4 or the decreasing pressure number 5, we will time with 100% in order to obtain the percentage error. So, next I will explain on how we obtain the relative error and the percentage error for this experiment. We take the example for the 1 kg of mass. For the increasing pressure, the relative error for the increasing pressure for 1 kg of mass is equal to the absolute value of the mean of the increasing pressure gauge minus the actual value pressure and divided this by the actual pressure, and we obtain the relative error is equal to 0.1051, and therefore the percentage error is equal to 10.51%. Next, for the decreasing pressure, for 1 kg of mass, the relative error is equal to the absolute value of the mean of the decreasing pressure gauge minus the actual pressure for the 1 kg of mass and divided this with the total actual pressure for 1 kg of mass, and we obtain the relative error is equal to 0.1483, and the percentage error for this 1 kg of mass is equal to 14.83%. This calculation will be repeated for all the mass throughout this experiment. The next part will be explained by my friend. Thank you.
I'm Sinlei. Now I will explain about the discussion of this experiment. For part 1, my teammate had discussed about the calculation part, and I will continue to discuss about the graph that our group conducted for this experiment. Figure 5.1 is the graph of Bourdon gauge pressure for increasing and decreasing orders of weight versus actual pressure. Based on figure 5.1, the Bourdon gauge pressure and the true pressure increase. From this graph, we can see that they do not have any interception, as there are some errors occurs in this experiment that cause the measured pressure is different with the actual value. Besides, figure 5.2 is the graph of percentage error for increasing and decreasing orders of weight versus actual pressure. From this graph, we can notice that the percentage error is not consistent and the accuracy of measured pressure is lower. For part 2, there are some errors occur in this experiment that cause the less accuracy of the result. Firstly, the air bubbles might be trapped inside the tube. Then, the less accuracy of the value of gauge pressure might be caused by the reading of Bourdon tube pressure gauge, which increases slowly and the piston is not totally static when the depth wave tester is removed from or add on to the piston. Besides, parallax error is also one of the errors happens in this experiment. To minimize this error, in order to obtain a more accurate result, the presence of air bubbles inside the tube should be removed by rotating the piston slightly. For recording the reading of gauge pressure, the reading should be taken after a few seconds to make sure the pointer is stable and maintained at fixed reading for a while. Lastly, the eye of the observer must be perpendicular to the scale of reading of Bourdon gauge when taking the value of gauge pressure to avoid the parallax error. For part 3, repeatability is defined as the closeness of the agreement between the results of successive measurement of the same measure when carried out under the same condition of measurement. Besides, the definition of accuracy is the closeness of the result of a measurement, calculation, or specification conforms to the correct value or standard. In general, an experiment is repeated for several times can increase the accuracy of the result. This experiment is repeated for 3 times to obtain a more accurate data, and the gauge pressure reading obtained are only slightly different from each other for every repeated experiment. From figure 5.1, the graph shows that the experimental value is almost same with the actual value. In conclusion, the accuracy of experiment can be improved by repeating it for several times. Thank you.
For the conclusion, to conclude, the calibrated pressure of the Bourdon gauge is closer to the true pressure applied when the weight are heavy. The percentage error is slightly high when 1 kilogram of weight is applied, and then the error can be reduced when prevention step is applied. And next, the accuracy of Bourdon gauge tube is higher when heavy weight it loaded with heavy weight. Therefore, it is very suitable in measuring high pressure compared to other equipment. Thank you.